Welcome to Math with Mrs. Seeley. Let's begin this 2025 free response question number 3. In this question, we're told that there is a student that's reading a book at time t equals 0 and continues reading this book for the next 10 minutes. The rate at which the student reads is modeled by this function, where it's measured in words per minute. Then they give us selected values in this table. In A part, it says to find R prime of 1 using average rate of change over the interval from 0 to 2. All right, average rate of change is the slope. And when we say slope, we mean slope like the slope you've been using for many, many years. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in this chart, the top row represents your x's and the bottom row represents your y. They want r prime of 1. Well, in my chart, 1 falls between those two values, which makes sense why they told me to use 0 to 2. So I'm just going to simply use my formula, y sub 2, which is 100, minus y sub 1, which is 90, over x sub 2 minus x sub 1, and I get 10 over 2, which is 5. If you were able to get that value, give yourself the first of the 9 points for this essay question. It also says to indicate units of measure. So if I want to indicate units of measure, go back up over here, and we know it's the y's over the x's, so you could just write the words with y over the words for x. So I would say words per minute, because that's the expression that goes with y, per minute. That's the expression that goes with x. You could also write that as words per minute squared. If you were able to get your units of measure, give yourself another point. The second part, B, it says, must there be a value for C in the interval from 0 to 10 such that R of C is equal to 155, and we'll justify our answer. In this particular question, and the more of these that you do, you'll recognize what they're asking when you see this. You're using the intermediate value theorem. In order to use the intermediate value theorem, you have to be a continuous function. So the function, or we're told in the problem that R is differentiable. So if it's differentiable, we know that it's going to be continuous, which is going to be a requirement to use this. So therefore, you must state that, and they give you a point. If you realize that differentiability implies continuity, give yourself the point. Then we know from 0 to 10, let's look at what the values are. So if I go back up here to my table, at 0 we're 90, and at 10 we're 162. And they just want to know, are we going to be 155 somewhere in that interval? Think of it in terms of this. If time is continuous, which it is, and we need that, like I said, as part of the reason to use this theorem, if you go from Monday to Thursday, you know you're going to pass through Tuesday and Wednesday. So therefore, I know if I'm continuous and I'm going from 90 to 162, I'm surely going to pass through 155. That's the simple way of thinking about it. But they're going to want you to say this. Since you know that R of 0 is equal to 90, and R of 10 is 162, and 155 falls between those two values, kind of like if this is Monday and this is Thursday, and I know that Tuesday and Wednesday fall between those, there will exist a value C such that R of C is equal to 155. It's the intermediate value theorem that allows you to do that. What they are looking for is that you state these things right here, that you state the values of these two endpoints, and you show that what they want you to equal is between those, and then that there exists this. One of the things that helps is go back to your problem and just kind of copy that part right there. You do not have to state intermediate value theorem to get your point. If you do state a theorem, you must state the correct theorem. Okay, let's look at C part. C part says to use a trapezoidal sum with 3 subintervals indicated by the table to approximate this value. Well, you guys know that the area of a trapezoid is 1/2 the height, parentheses, base 1 plus base 2. The height is your delta x, or the distance between the different intervals here. So we know that the interval from 0 to 10 of r of t is equal to 1/2, because that's in front of everybody. Now let's go find that delta x and those bases. So I'm going to come up here. In this very first interval right here, my delta x, or the space between that, is 2. And this is base 1, and this is base 2. So we're going to come back down here. Let's write that out. So 1/2, we said the first delta x is 2. The first base was 90, plus the second base was 100. Plus, let's go to the second trapezoid. It's 1/2. Let's come up here and find our delta x. Our delta x for this one, from 2 to 8, that delta x is 6. And this is my base 1. And this is my base 2. So let's come down here and put it into our Riemann sum. So it's 1/2. We said that height, or that delta x, is 6. The first base was 100, plus the second base is 150. Then plus the last one is 1/2. Let's go up there and find our delta x. So looking at this right here, our delta x from 8 to 10 is 2. This would be our base 1, and this would be our base 2. So let's come back down here and put it in our Riemann sum. So that's 1/2. 2 was delta x. The first base, again, was 150. The second base was 162. If you got your Riemann sum for your trapezoidal sum set up correctly, give yourself a point. All right, now let's evaluate it. Right here, personally, I would take that 2 and that 2 and cancel those. And 90 plus 100 is 190. Plus, I would say 2 goes in there 3 times. So I have 3 times 250. Plus, I'm going to let those cancel. And if I say 150 plus 162, I get 312. Now, if you get this, they're actually going to give you a point for that. They would allow you to earn that point from there. If you go ahead and give them the answer, the rest of it, that's 190 plus 750 plus 312. And if you kind of add all that together, you get 1,252. If you get that, those are your 2 points for C part. All right, D part says this. A teacher also starts reading at time t equals 0 and continues to read for the next 10 minutes. The rate, which means that's a derivative that she is reading, is right here by WT in words per minute. Based on the model, how many words has the teacher read by the end of 10 minutes? And we're going to show our work. Well, we need to integrate her rate from 0 to 10. So I'm going to integrate the rate at which she reads. Now, if you'll remember, if you integrate, and this is a very powerful, it's called the net change theorem, but if you integrate a rate, you get the net change. Basically, if I integrate the rate that she's reading the words, I'll get the number of words that she actually read. So if you knew to do that, if you knew to integrate that rate of change from 0 to 10, give yourself a point. Now let's actually do the integration. So from 0 to 10, if I put in my function that was -3/10, t squared plus 8t plus 100 dt. This is a pretty simple integration here. So I'm going to add 1 to it, which is 3, divide by 3. Of course, those 3's are going to cancel. And I get negative 1/10 t to the third plus here, that's the first, add 1 to it, which is 2, divide by 2. And you get 4t squared plus 100t. And I'm going to evaluate that from 0 to 10. If you got that integrated correctly, give yourself another point. Then we're going to put our 10 in wherever there is a t, plus 4, 10 squared, plus 100 times 10. And then we're going to minus, put your 0 in. I love putting zeros in when it's all going to be 0. So this is going to give me 1,000, but times that would be negative 100. Plus that's going to be 10 squared is 100 times 4 is 400 plus 1,000, which is going to give me 1,300 words. If you were able to get this right here where you put the 10 in and you minus putting the 0 in, give yourself the other point. You did not, again, necessarily have to tell them 1,300 words. They would have accepted the answer right there. I hope you found this helpful for your AP Calculus exam preparation. If you did, please like, comment, and subscribe to the channel, and be sure to check out other AP Calculus explanation questions, as well as other tutorial videos on the channel. See you next time.